Hope you all are well. So today we will start a new chapter, solution. It is basically the first chapter in plus 2 class. Solution. What we understand from this term, solution is basically what? When we mix any two or more substances together, then it will leads to the formation of solution. For example, if we mix salt in water, what will happen? Here these are two components, one component is salt and another component is water. When these two we are taken together, then it leads to the formation of solution. Another example is salt, sugar in water. This is again a solution. Next example is tincture of iodine. Tincture of iodine. Tincture of iodine means this is when iodine is mixed with alcohol. Tincture of iodine, air, these all are the examples of solutions. Now this solution consists of two components. It has two components. What are these two components? One component is solute and another component is solvent. The component which is present in larger amount, that is solvent, and the component which is present in less amount, that is solute. For example, if we talk about salt in water, here we add salt in water. This indicates this salt is present in lesser amount and this water is present in more amount. So here this salt is a solute and this water is solvent. So these are the two components of the solution which together form solution. In this example, sugar in water. This sugar is a solute and water is solvent. Now come to tincture of iodine. This means iodine present in alcohol. So here iodine is solute and this alcohol is a solvent. Now air. In the air there is number of gases present, but the highest amount of nitrogen is present. 78% is nitrogen and rest is all the other gases. So here solute is other gases and solvent is nitrogen because nitrogen is present in large amount. This is all about the solute and solvent. Now we have to understand certain terms related to solution. Homogeneous and heterogeneous. Homo means same. So the solution in which both solute and solvent are in same phase. For example, both are liquids, both are solids, both are gases. Then it is homogeneous. For example, air is a homogeneous mixture because here solvent is nitrogen and solute is also gases. So it is homogeneous mixture. And heterogeneous solution is, hetero means different. So if solute and solvent is different phase, then it is heterogeneous. For example, salt in water. Salt is solid and water is liquid. Next, saturated and unsaturated. Saturated means, saturated solution is that solution in which more solute will not be added. Means maximum solute is already added. For example, if we talk about, if we have take 1 glass of water and we add 1 spoon of salt or either sugar in it, it will completely dissolve. After that we put 1 more spoon of salt in it, it will also dissolve. If we add 2 more spoons, then it will dissolve or not. The solution after adding 2 spoons becomes saturated. Means जितना solute ਉਹਦੇ ਵਿੱਚ dissolve ਹੋ ਸਕਦਾ ਸੀ ਉਹ ਹੋ ਚੁੱਕਿਆ. Further no more solute will be added. That solution is called saturated solution. And the solution in which we can add more amount of solute, then it is called unsaturated. It can be understood with the help of this. In organic chemistry, you have already studied about alkane, alkene and alkyne. You have remembered that we call these two are unsaturated and to this carbon is saturated. Here we will not add any hydrogen. We will not do addition here. Here we will do substitution. But here we can add hydrogen. Here two hydrogens will add, this bond will be removed. Here hydrogen will be added and this bond will be removed. So these both are unsaturated, in which we can add something. The substance in which we will not add something, that is saturated. Means the maximum जिन्नी add करने की capacity से वो खत्म हो चुकी है. That are saturated solution. Those solution in which we can add something, that is unsaturated solution. Next come to binary solution. Binary means, bi means two. The solution which has two components. Means if we talk about these all components, sugar in water. Sugar is one component and water is another component. So these are the examples of binary solutions. Let's proceed further. There is another term, that is concentration. Now what is concentration? Consider an example. This is a beaker. In this beaker we have taken 2 spoons of sugar, A case, and here is another beaker. In this beaker, this is 1 cup. Instead of 1 cup, you can write 10 ml. Here it is again 10 ml and here 4 spoons sugar is added. We have taken 100 ml. Now consider A and B case. In A, there are 2 spoons in 100 ml solution. And here is 4 spoons of sugar in 100 ml solution. Here 100 ml is constant. So amount of solvent is constant. So solute will be changed. Here 2 spoons and here is 4 spoons. Amount of solute is more in which case? Case B. So this solution is more concentrated. Means more amount of solution is present. So this is concentration. Now if we consider another example, here is the beaker. In this beaker we had 2 spoons of sugar and this is 100 ml. Again 100 ml. This is C case, and in D case what will happen? Here we add 2 spoons, but these 2 spoons are present in 400 ml of solution. Now in this C and D case, tell me which is more concentrated. Here the amount of solute remains same, but the amount of solvent is changed. According to this amount of solvent, in which sample the amount of solute is more? It will be more in this C case, because 2 spoons are dissolved in 100 ml. Here 2 spoons are dissolved in 400 ml. So here the amount of solvent is more. When the amount of solvent is more, then concentration is less. Concentration of solute is less. Amount of solute is less. So this solution will become more concentrated than this D solution. So this is all about the concentration. Now another topic is how to represent these concentration terms. Now we will discuss some concentration terms. First one is weight to weight, weight to weight percentage. This means weight to weight, means weight divided by weight. So it is amount of solute divided by amount of solution, total amount of solution, multiply by 100. To calculate the percentage, this is the formula. If we talk about the total marks, we will calculate marks obtained divided by total marks multiply 100. Then you will get the percentage of your marks. So in the similar way, we can calculate the weight to weight percentage. The amount of solute which we want to calculate the weight for that component and total amount of solution whatever whole compound is given. For example, if we talk about CO2. If we want to calculate the weight of carbon in the CO2 molecule, what will be happen? Amount of solute means amount of carbon, then amount of solution, this whole we consider. So this is the way to calculate the weight by weight percentage. Second है volume by volume percentage. Volume by volume percentage. What will happen in this case? We have taken amount of solute. Here we take volume of solute divided by volume of solution multiply by 100. So this is the way to calculate volume by volume percentage. Third is weight by volume percentage. Weight by volume percentage. Weight. So weight is amount of solute by volume means volume of solution, then multiply by 100. There will be very less numericals directly related to this concept, but this thing is used in certain further numericals. We will see in the questions how these can be used. So these are the three concentration terms: weight to weight percentage, volume by volume percentage, and weight by volume percentage. Let's proceed further. Next is ppm. ppm is parts per million. This will be applicable when the amount of solute is present very less amount. Means it is present in traces. Means the amount of solute will be 0.0003 gram. Like this. Then we use ppm. The formula for this is amount of solute divided by amount of solution multiply 10 raised to the power 6. Here we use instead of 100 10 raised to the power 6. Next is molarity. These terms are somewhat important. Molarity. Now what is molarity? It is the number of moles of solute present in 1 liter of solution. Means how many number of moles present in 1 liter of solution. Means there is the solution which is 1 liter. The number of moles present in it, that is called molarity. Now the formula for this molarity, we will represent it with capital M. Number of moles divided by volume of solution in liter. If we consider this formula, now you can also calculate the units from here. Number of moles. Unit is moles, so mole. Volume of solution. Unit is liter. Here it is in denominator, so it is mole per liter. So this is the this is the units of molarity. This is the formula. If we want to calculate, if we want to put volume here in ml, then what will it become? number of moles divided by volume of solution in ml. You have to represent, multiply 1000. If we put here volume, value of volume in milliliter, then we have to multiply here with 1000 to get the value of molarity. Now here we use number of moles. So number of moles can be calculated. Number of moles is equals to given mass, which is already given in the question, divided by molecular mass, molar mass. Means if we talk about CH4, its mass is given in the question, that is given mass, and its molecular mass, that is 12 plus 4 equals to 16, that will be its molar mass. By putting this you can calculate number of moles, and then you put number of moles here and you will get molarity. This is about the molarity. This molarity is temperature dependent. This molarity is temperature dependent because molarity is inversely related to volume. But when we change the temperature, this volume will be changed because volume depends on the temperature. So as molarity depends on volume, so it also depends on temperature. Next term is molality. This is number of moles dissolved in of solute dissolved in 1 kg of solvent. In molarity, you have taken the volume of the solution. Here we are taking 1 kg of solvent. So what will be its expression? It is represented by small m, which is number of moles divided by mass of solvent, which is in kilogram. From here we can calculate its units. Now the units of moles is mole. Unit of mass is kilogram. It is present in denominator, so mole per kg. Now you can also represent number of moles. If we put this mass of solvent in gram, then we have to multiply here with 1000. This is molarity. As this molarity is independent of volume, it depends on mass. Mass will not change with the temperature. So due to this reason, this molarity is the better term than molarity and normality because it is temperature independent. It will not depend on temperature. So it is temperature independent. Now next term is normality. In normality, what is the difference? It is represented by capital N. Number of gram equivalents. Number of gram equivalents dissolved in per liter of solution. Per liter of solution. Now what is saying? Capital N, number of moles, number of gram equivalents. Number of gram equivalents divided by volume of solution in liter. If we take ml, then we have to multiply with 1000. Now here the question arises, what are gram equivalents? As we know about the molecular weight, if we consider example H2SO4, here it will break and it will give 2H positive and SO4 2 negative. Here it will give 2H positive. So what is the molecular weight of this H2SO4? This is 98 grams. Here, this is an acid. This is a sulfuric acid. This is acid. It will give 2H positive to the base. As it will give 2H positive to the base, so its basicity will be 2. Any acid have the basicity and the bases have the acidity. This acid will give 2H positive to the base. So its basicity is 2. Now for gram equivalent we have to calculate equivalent weight. Equivalent weight. What is an equivalent weight is? This is molecular weight divided by acidity in case of bases or basicity in case of acids or valency in case of salts or number of ions in case of salts. So this is the formula to calculate equivalent weight. Now for this case, molecular weight is 98. Here this is an acid, so we will consider basicity. Basicity is 2. On calculating you will get the answer, that is 49 gram. This will be the equivalent weight of this H2SO4. Now next thing is to calculate this gram equivalent. Still we have not reached this gram equivalents. We get the equivalent weight. Now to calculate number of gram equivalents, what will be the formula? What will be the formula of number of moles? In number of moles we will take the given mass over molar mass. So for number of gram equivalents, what will be the formula? Given mass divided by, instead of molar mass we will put equivalent mass. If we consider in a question the mass of H2SO4 is given 5 gram. 5 gram. Then given mass is 5. Equivalent mass is 49. So these are the number of gram equivalents which we put in the formula of normality. Then after this we will put the formula normality, which is number of gram equivalents divided by volume of solution in liter. After this you will calculate normality, and from here we can get the units of this. The units of gram equivalent is gram equivalent. Unit of volume is liter. So gram equivalent per liter. So these are the units of normality. So this is the case we have taken. This is the case we have taken about the acid. If we have taken the base, then for base we have considered acidity. It will be reverse. For acid it is basicity, and for base we have to consider acidity. For example, NaOH. This is the base. Its molecular mass is 40. It is a base. When it will split, it will form Na positive and it will give one OH negative to the acid to combine. So its acidity will be 1. As its acidity is 1, then its equivalent weight will be equals to 40 divided by 1, which is 40 gram. Now, if we talk about metals, iron plus 2 changes to iron plus 3. If we want to calculate the equivalent weight of this, here the number of electrons change. Plus 2 to plus 3. Change of electron is 1 electron. So we can calculate molecular weight divided by change of the number of electrons, 1. So this will the way to calculate the equivalent weight. As the normality is number of gram equivalents divided by volume. As it depends on volume, so this is also depends on the temperature. So this is also temperature dependent quantity. Now next is mole fraction. Mole fraction. The way to calculate the mole fraction is we have to consider number of moles of that component to whose we want to calculate the mole fraction. For example, for solute we will consider number of moles N1 for solvent and N2 for solute. Then what will happen? If we want to calculate mole fraction of a solute, then it is represented by X2. Here number of moles of solute divided by total number of moles. So we can also write it as N2 divided by N1 plus N2. So this is the way to calculate mole fraction of that component. Another thing, the mole fraction of both the components X1 plus X2 will always be equals to 1. So if we calculate the mole fraction of one component by using this formula, we can calculate the mole fraction of another component. As this mole fraction depends only on the number of moles. If we talk number of moles will depend on mass. So it is independent of temperature. So this property is also temperature independent. Now the last concentration term is mass fraction. Mass fraction. As here we consider the mole fraction. So we are using the moles. To calculate the mass fraction, what we will consider? Weight of solute divided by total weight. Means solution total weight means what we can write? Weight of solute. If we want to calculate the mass fraction of solute, then weight of solute divided by weight of solute plus weight of solvent. So this is weight of solute divided by weight of solute plus weight of solvent. We can also write it as W2 divided by W2 for solute and W1 for solvent. So these are all the concentration terms and the ways to express it. In the next video, we will discuss the numericals related to these concentration terms. That's all for today. Thank you and have a nice day.